Hi, today we're going to do lesson 1.6, Classify Polygons. The big question here is, how do you classify polygons? So in order to do this, we need to know all about polygons. So take out your All About Polygons frame and let's put that together. So All About Polygons is about the basics of polygons. Polygons are closed plane figures with specific properties, names, and classifications. So we're going to include those on this frame. So the first main idea is properties of polygons. So polygons are formed by 3 or more line segments called sides. So that means your sides have to be line segments. They cannot be curved. Second thing, each side intersects exactly 2 sides, one at each endpoint. So no 2 sides with a common endpoint are collinear. An example of this, if I had a shape that looked like this, I could not have a line touching. I could not have that line going through the middle. That is not going to be a polygon. Our next idea is naming polygons. So in order to name them, you list the letters of the vertices in consecutive order. So you go right around the shape and you can start with any vertice. Convex versus concave. So it's convex if you can draw a line along any side and it doesn't go inside the polygon. So for example, here's a triangle. If I draw a line along this side, it does not go inside the polygon. If I draw a line along this side, it does not go in the polygon. If I draw a line along this side, it does not go inside the polygon. So that is a convex shape. If the line does go inside the polygon, it's non-convex or concave. So let me draw another shape here. Okay. Imagine these sides are perfectly straight. So using this shape, if I drew a line along this side, it would go inside of my polygon. So that would be concave. And I like to think of concave also as caved in. It's got a side that's caved in. To classify them, we classify by the number of sides. So if it's 3-sided, it's a triangle. 4-sided is a quadrilateral. 5-sided is a pentagon. 6-sided is a hexagon. 7-sided is a heptagon. 8 is an octagon. 9 is a nonagon. 10 is a decagon. 12 is a dodecagon. And anything else would be with n sides is called an n-gon. So if I had 11 sides, I would just call that an 11-gon. Or 24 sides, I'd call it a 24-gon. Our last main idea is classifying by length and measure. If we have an equilateral thing, it tells us our sides are congruent. Equiangular tells us we have congruent angles. And regular tells us a few things. If it's regular, that means it's convex, it's equilateral, and it's equiangular. So if you see a word problem that says a shape is regular, you know all 3 of those things are true about that shape. Our so what statement for this frame is we need to be able to classify polygons so we can accurately describe them. So make sure you've got this frame all completed, and now we're going to do the notes that go along with this lesson. So example 1, identify polygons. Tell whether the figure is a polygon and whether it's convex or concave. Well, if you look at this first one, you'll remember we cannot have a line going through the middle of our shape like that. So this one is not a polygon. This one, all the sides are straight, and each endpoint, each side touches another side, and it only touches one other side. So this is a polygon. And if you look, there are no sides that are caved in, so this is a convex polygon. I could draw a line along any of these sides, and my line along any of these sides will never ever go inside of my polygon. see here, yep, it's a polygon. All the sides are straight. They all touch. Each side touches another side at only one endpoint. So yes, this is a polygon. But if you look right here, if I drew a line along this side, that line would go inside of the polygon. So this would be called a concave polygon. It's like this side right here is caved in. So you try these examples, pause it and try them, and then come back and listen to what the actual answers are. So the first one, yes, this is a polygon, and it is convex. Number 2, because it's got this curved side right here, it is not a polygon. Example 2, classify polygons. So classify the polygon by the number of sides. Tell whether the polygon is equilateral, equiangular, or regular. So here's 1, 2, 3, 4, 5, 6, 7, 8 sides. And if I have 8 sides, that is an octagon. If you notice, all these sides have one line marking on it, telling us that the sides are all the same length, but also there's one arc for each angle, and that tells us the angles are all the same. So all the same side lengths, all the same angles makes this a regular octagon. And you've got another example on your notes, and your other example has a picture that looks like this. So let's classify this one as well. Let's follow the exact same directions for this shape. There's 1, 2, 3, 4 sides, so we're going to call this a quadrilateral. These two angles are the same, and these two are the same, so it's not equiangular because we've got different angles. This side and this side are the same, but we don't know about those other two sides, so it's also not equilateral. So all we can say is that's a quadrilateral. Example 3. The head of a bolt is shaped like a regular hexagon. The expression shown represents side lengths of the hexagonal bolt. Find the length of the side. Well, there is a key word in here, and that is regular. As soon as you see that it's regular, you can say, oh, all these side lengths are the same, and all these angles are the same as well. The question says, find the length of a side. Well, since these sides are the same, we can set these two expressions equal to each other and solve for x. So 5x minus 1 equals 4x plus 3. Subtract 4x from both sides to combine our like terms. So I have x minus 1 equals 3. Add 1 to both sides and x equals 4. Now the question said find the length of a side. We found x, so we haven't answered the question yet. So let's plug x in here. So 5 times 4 minus 1, that's 20 minus 1, which is 19. And a good double check will be to make sure we get 19 for this side as well. So 4 times 5 plus 3. Oh, not 4 times 5. 4 times 4 plus 3. That's 16 plus 3, which is 19. So we got that our side lengths are both 19, which is they're congruent, which we know that's true. So we found the right answer. Our side length is 19. Here's the example that we were missing. Got some slides in the wrong order here, but we've already done this one. We said it was a quadrilateral. Example 3. We just did this one as well. Got some slides out of order here. Let's do this next one, our final example. The expressions 4x plus 8 and 5x minus 5 represent the measures of two of the congruent angles in example 3. So I went ahead and put your picture on here from example 3. Find the measure of an angle. So these are our side lengths. We're now looking at our angles here. And since it's a regular shape, we know that all of our angles are equal, so we can take these two angle measures and set them equal to each other. So I can say 4x plus 8 equals 5x minus 5. I'll move my smaller variable. So I have 8 equals x minus 5. I can add 5 to both sides. X equals 13. So the question says, find the measure of an angle. Well, we found x, but we have not found the measure of an angle yet. So I'm going to plug my x into one of the expressions. So I've got 5 times 13, that's 65, minus 5 is 60. So we think our angle measure is 60. Let's just double check in the other as well. So we're going to check in this other angle measure expression as well. So 4 times 13 plus 8, that's 52, plus 8, which is also 60. So using both expressions, we found our angle measure to be 60, so they're congruent, which is what we want. So our angle measure is 60 degrees. And that is the end of this lesson. So have a great day.